Hi again. In this video, I will be talking about um, how we can identify the connections between resistors in a combination situation of a parallel and series. So there will be no numbers, no calculation in this video. It's just how we can handle an electric circuit and identify which part of these resistors are in series, which one is in parallel, and so on and so on, and how we can shrink our circuit and make it really simple. Now, generally speaking, usually we start on the opposite side of the battery. So if my battery on this side here, as you can see it's on the left side between AB. So what I can do is, generally speaking, we start on the opposite side. So where is the area of the resistors 2, 5, and 3. But there are some cases where I can use or I can start in the circuit in certain branches where they are kind of like they are can be done by itself or by themselves without looking to the opposite. Like in our case here, this region here, these three resistors, they can be, we can start with them, it's fine. But let's follow the steps. So as a start, we have R2 and R5 in series. So I can call that as an R equivalent one. Some people might call it R25. That's fine. It's representing the same thing. Now, the result of this, it will be I kind of like taking these out and replacing them with a new resistor, the same, it's the equivalent, and it will be R equivalent 1. Okay, so I could draw my circuit to be like this. Only that part from where is the point B, it will be that will be R equivalent 1 with R3. Okay, now the next step is will be I have R3 and R equivalent 1 in parallel. All right, so the equivalent of them, I can call it R equivalent 2, as it is the second equivalent we found in this circuit. Now, if I want to draw my circuit, it will be like this now. So I will have one resistor here. It's the R equivalent 2, and I will have here sorry, the R4, R1, and R6. Okay, so this one here, R equivalent to, it is what we found from the area or the region where I have all three resistors. Okay, now we can take these off to keep it tidy. Now let's continue with the circuit. What I have now, it's kind of like repetitive of what we did with the region R2 and R5, but in this case it is R1 and R4. They are in series, so I can start. So I can say, all right, this is R1 and R4 in series. All right, let's just take this off a bit, and I will call it R equivalent 3. Okay, so still I have my R6 here, and I will have a new one, or the equivalent, it is R equivalent 3. And I will not forget that I still have my R equivalent 2. Okay. Now the next step, it will be R equivalent to 3 and R6 in parallel. Call it R equivalent 4. That will give us that's our R equivalent 4. This is R equivalent 2. And still, that's the two potential difference point, A and B. And you can see now we end with two resistors. I can just draw here the last bit, where R equivalent 4 and R equivalent 2 are in series. That will give me the total R equivalent, which is, here's point A, that's point B, and this is our R equivalent total for the whole thing. Okay, so this is just to practice and see how your circuit is shrinking from certain point to another point and another level. So we started with the big one here, or the full circuit, and we said, okay, R2, 5 series, then they are parallel, the equivalent, and then we move to the other part of the circuit, the 4 and 1 series, whatever equivalent of them parallel with 6, but the equivalent of the whole thing, it's a series ended with 2 R equivalent in series, as we can see here.